Here's another property of radical. Square root of a over square root of b is the same as square root of a all over, over b. Or the square root of a over b is equal to the square root of a divided by square root of b, vice versa. Okay? So we'll be using this concept in rationalizing denominators. We consider this problem, number 48, square root of 5 over 3. You can rewrite this as square root of 5 over square root of 3. To rationalize denominator means to get rid of a radical in the denominator. So that's what it means by rationalizing the denominator. So I repeat, rationalizing the denominator means we must get rid of your radical in your denominator. So for 48, you have square root of 5 over 3. We can rewrite that as square root of 5 over square root of 3. So we must get rid of the radical here, and we can do that by thinking of a number to be multiplied to 3 so that it becomes a perfect square. And usually we think of that number itself, right? 3 times 3 is equal to 9, but it's not always the same number. Just think of the smallest number to be multiplied to 3 to make it a perfect square. And that is 3. 3 times 3 is equal to 9. Therefore, we multiply this numerator and denominator by square root of 3 over square root of 3. Square root of 3 over square root of 3. Okay, so let's multiply this. Can you multiply this? Both are radicals. Yes, they are both radicals. So that means we can multiply 5 and 3. 5 times 3, 15. So we have square root of 15 over square root of 9. But what's the square root of 9? 3. So we have square root of 15 over 3. We are now done. We have rationalized the denominator, no more radical. So square root of 15 over 3 is equivalent to square root of 5 over 3. Square root of 8 over square root of 3. We can think of a radical that will make this a perfect square root. So we can multiply this by, what's this? To make this a perfect square root, we can multiply it by square root of 3. Okay, so we have a square root of 3 over square root of 3. Can we multiply this? Both are radicals. So we have 8 times 3, 24, 9. And then we have square root of 24 over the square root of 9 is 3. But we have to look at our numerator. Can we simplify square root of 24? Let's try out all factors of 24, wherein 1 is the biggest perfect square factor. What are the factors of 24? We have 1 times 24, what else? But none of them is a perfect square except 1, but we cannot use that. 2 and 12, none of them is a perfect square. 3 and 8, none of them is a perfect square. 4, 6, one of them is a perfect square. 4, what else? Do you think we have other factors? Only these factors? What else divides 24? Divisible by 6, but you already have it here. Divisible by 8, but you already have it here. Which one here is the biggest perfect square? This. So you have to use 4 and 6. All right, so we have the square root of 4 times 6 over 3. Now take the square root of 4. What's the square root of 4? We have 2. All right, so you have 2 square root of 6 over 3. Question, can you divide 6 by 3? No, because this one is radical, this one is not. You can only divide if both of them are radicals, all right? Just like when you multiply, you can only multiply if both of them are radicals with the same index. You cannot multiply radicals with different indices, just like square root of 2 and cube root of 3. You can only multiply them after rewriting them into same indices. But if they have different indices, you cannot multiply immediately. You need to rewrite. So we have 2 square root of 6 over 3. You cannot simplify that further.